Hello, my name is Jeff Jennings, and I'm going to give you a super quick demo on how to run a Frankenstein fit to recover a 1D radial brightness profile for a protoplanetary disk at super resolution in less than a minute from the terminal. So let's get started. I'm going to jump right to the Frank documentation on github.io. Here there's information, there are guides on how to install Frank, a quick start example for both how to fit from the terminal and how to fit interactively. Tutorials that detail what the fitting procedure is doing and how to interpret the results. But here we're just going to do the installation and an example similar to the quick start by running from the terminal. So we're going to fit the DSHARP observations of SR4, this compact disk here. And I already have a UV table for SR4 extracted from the MS table in CASA. There's a guide on the Frank docs for how to extract a UV table from an MS table. And I have a parameter file for SR4 that I'll show in just a second that we'll use for the fit. And those are the only two things we need. So first, I created a cond environment for this demo. So it just has NumPy, SciPy, and Matplotlib installed because those are the Frank dependencies. So I'm going to activate that, and then I'll just install Frank, pip install Frank. Cool. And then we'll just take a look at that parameter file. So Atom, we'll look with Atom sr4 parameters.json. So that's here. So the only things we've changed from the default values in the default parameter file are we've given the UV table file name. We've specified that to deproject the visibilities, we'll supply a known geometry. And these are the published values from DSHARP 2, that's Wang et al. 2018a. So the inclination, position angle in degrees, and the RA and deck offsets in arcseconds. And then we've set the outer radius of the fit. So SR4 is pretty compact. So 0.4 arcseconds is larger than the edge of the disk, and that's really all that matters in terms of choosing an exact value. And then we've set the number of points in the fit, a reasonably large number given our R out. And then we have our two important hyperparameters, alpha and W smooth. These are both discussed in more depth in the Frank docs, and then especially in the Frank methods paper. But right now we're just going to use the default values for these two parameters because they tend to work pretty well. So usually you vary alpha between 1.05 and say 1.5 for a fit and just compare the results between the different fits and ensure that Frank isn't fitting too far into the noise, i.e. isn't fitting to noise-dominated baselines, which can happen if you choose alpha too small, too close to 1. But usually this is a pretty good value. And W smooth usually vary between 10 to the minus 4 and 10 to the minus 1. Usually the fits are less sensitive to that and more sensitive to alpha. So we're going to use the default values. So we have our UV table and our parameter file. So let's run the fit. So we'll do python-m to call a module. Frank.fit is the module we call the run from the command line. .uv, so that's just our UV table. We already gave it in the parameter file, so we don't have to give it here as well, but just to show you the UV flag. And then -p is our parameter file name. That's the one we were just looking at. The one we were just looking at, SR4 parameters. And that's it. So that's the one-liner. So the code tells us this is the UV table we're fitting. It saves our parameter file values to a new output parameter file. It loads in the UV table, determines the disk geometry to deproject the visibilities. We already gave it a geometry, so it tells us what those values that we supplied were. And then it starts fitting for the brightness profile. So first it builds these two matrices that are kind of large, so we build them up in chunks. And then starts running the fit until it reaches a convergence criterion, which it has. And then it tells us that it fit the profile using the data sets 7 times 10 to the 5 visibilities and 150 points in the fit in about 20 seconds for SR4. And then plotting the results. So we just by default make a quick figure that shows us the output of the fit. And then we save a bunch of fit outputs to different files that are all described in the documentation. Clean up the plots a bit and compare the Frank profile in red to the clean profile in blue for SR4. So the visibility fits here, the brightness profile is here, and then the 1D Frank brightness profile swept over 2pi in azimuth and reprojected by the geometry the fit used, and that is compared to the clean image. So we can see the super resolution aspects of the clean fit. And that's it. So it just took us about 20 seconds to run a fit from the terminal for a DSHARP dataset using just the UV table and the parameter file. So yeah, thanks a lot, and hope it was helpful.